En menos de 24 horas, el tercer objeto interestelar jamás descubierto desaparecerá. No explotará, no se desvanecerá, sino que se esfumará, deslizándose directamente detrás del Sol, donde ningún telescopio podrá seguirlo. Los astrónomos lo llaman conjunción solar. Yo lo llamo el universo cerrando su telón. Por primera vez en la historia, un visitante interestelar alcanzará su momento de mayor energía completamente oculto a la vista. ¿Qué sucede en ese silencio? Nadie puede decirlo. Así que esta noche, mientras dos cometas verdes cruzan nuestros cielos, en lo que algunos consideran una posible distracción del universo, un tercero desaparece en el Sol. Acompáñenme hasta el final mientras analizamos lo que 3 Atlas está a punto de hacer. Porque lo que descubramos al final cambiará por completo tu opinión sobre los visitantes interestelares. Si esto te tiene tan nervioso como a mí, no te quedes mirando desde la barrera. Dale a me gusta y suscríbete ahora mismo para no perderte la siguiente pieza de este rompecabezas. Comenta abajo desde dónde lo estás viendo, qué hora es y si crees que la verdad se está revelando o se está enterrando. Y si crees que otros también merecen verlo, compártelo, comuníquenlo en X, publíquenlo en sus grupos de chat, compártanlo donde puedan y descubramos este misterio juntos. Primera parte, el punto de fuga. En menos de 24 horas, algo sin precedentes ocurrirá. Un objeto de otro sistema estelar, designado como Atlas de 3 ojos, se esconderá tras el Sol y desaparecerá de todos los telescopios de la Tierra. Este no es un evento astronómico, más que te perderás si pestañeas. Esto es diferente. No hay cometa ni visitante interestelar. Nada de lo que hemos rastreado ha logrado lo que Atlas está a punto de lograr: alcanzar su punto más cercano, más rápido y más energético en su viaje, volviéndose completamente invisible para nosotros. Los científicos lo llaman conjunción solar. El término suena clínico, casi aburrido, pero lo que describe es todo lo contrario. Una conjunción solar ocurre cuando el Sol, la Tierra y un objeto objetivo se alinean de tal manera que, desde nuestra perspectiva, este se encuentra casi detrás del Sol. El intenso resplandor del Sol dificulta la observación, además de ser peligroso. Si apuntas un telescopio al Sol, no obtendrás dato. Están derritiendo equipo costoso, así que no miramos, no podemos mirar. Y durante las próximas semanas, mientras Atlas atraviesa la fase más dinámica de toda su trayectoria, estaremos completamente a ciegas. Les daré un poco de contexto. Atlas fue descubierto el 1 de julio de 2025 por el Sistema de Alerta de Impacto Terrestre de Asteroide, la misma red que busca rocas que podrían llevar nuestro nombre. Desde el momento en que los astrónomos trazaron su trayectoria, supieron que algo andaba mal. The orbit was hyperbolic, coming from outside our solar system entirely. This made Atlas only the third confirmed interstellar object ever detected. The first was one identified by Oumuamua, that strange cigar-shaped visitor that tumbled through our neighborhood in 2017 and sparked 1,000 debates about whether it might be artificial. The second was two identified by Boris in 2019, a comet that looked more normal, more like the AC wanderers we're used to. But Atlas is doing something. Neither of those objects did. Both Oumuamua and Borisov remain visible during their closest approaches to the Sunday. We could watch them. We could measure them. We could point every available instrument at them and gather data constantly. With Atlas we get none of that. The object reaches perihelion, its closest point to the Sun, on October 29th, 2025 at approximately 203 million kilometers, or about 1.36 astronomical units. That's when it's moving fastest, when solar heating is strongest, when tidal forces are at their maximum, and all of this happens while Atlas is hidden. Avi, the Harvard astronomer who made waves suggesting Oumuamua might be a light sail, has called this alignment extraordinary. He's pointed out the specific timing. Conjunction on October 21st, perihelion just 8 days later, on October 29th. These aren't events separated by months or years, they're back to back, and Loeb never want to shy away from bold speculation. Ask a simple question that lingers in your mind once you hear it. Coincidence or design? Now, before you think this is about to spiral into alien territory, let's be clear about what we're dealing with. Atlas is most likely a natural object, a chunk of ice and rock that got ejected from some distant star system millions of years ago and has been drifting through the galaxy ever since. Comets are chaotic, their formation regions are violent. Being flung into interstellar space is rare, but not impossible. We'd expect to see a few of these visitors over time as our detection methods improve. So, the existence of Atlas isn't shocking. What's shocking is the timing. Think about it this way. You're staging a play, and the main character walks off stage, right as the climax begins. The most important scene happens behind the curtain, while the audience sits in silence waiting. That's what we're facing. The most scientifically interesting phase of Atlas's journey. The moment when comets typically become most active, when they fragment or flare, or do something unexpected. All of that will occur while we're unable to observe any of it. We do have some tools that might catch peripheral data. Spacecraft like SOHO, the Solar and Heliospheric Observatory, and Parker Solar Probe, which is already closer to the Sun than any human-made object has ever been, might detect scattered light or changes in the solar wind as Atlas passes. Stereo satellites could potentially capture tail behavior, but these are indirect measurements, scraps of information compared to what ground-based telescopes would normally provide. We won't get spectroscopy to analyze the gases boiling off its surface. We won't get high-resolution imaging to check for jets or fragments. We won't get precise astrometry to refine its trajectory. And here's where the tension builds. Perihelion is exactly when comets get interesting. The sun's heat vaporizes ices, creating spectacular tails and comas. Internal pressure can cause sudden outbursts. Structural weaknesses lead to fragmentation. The comet you see going in is sometimes not the same comet that comes out. We've watched comets split apart, watched them brighten unexpectedly, watched them change trajectories slightly due to outgassing, acting like tiny
scattering
rocket
green
engines.
dust into the
All
rings.
of this happens at perihelion. All of this will happen to Atlas while we're not watching. So, what do we do with the next 24 hours? Observatories around the world are scrambling to gather final measurements. Last looks, closing snapshots. Every piece of data collected now will have to carry us through weeks of silence. Amateur astronomers with backyard telescopes are taking their shots, knowing that Atlas is faint but still technically visible if you know where to look. The astronomical community is in a race against the clock, trying to squeeze every photon of information out of this object before it crosses that invisible line and disappears into the sun's glare. And while we wait, while Atlas makes its hidden passage, a question sits with us. What if something happens behind that curtain? What if this interstellar visitor does something unexpected during the one period when we can't see it? When Atlas re-emerges on the other side weeks from now, will it be the same object that went in?
Can you hear
Or
me?
will we find ourselves staring at something changed, something different, trying to piece together what happened during that lost act? The countdown has begun. The vanishing point approaches, and the sky is about to go dark on one of the most extraordinary visitors we've ever received. Part 2. The silence window. Let's talk about what we're actually losing here. When astronomers say we'll be blind for several weeks, they're not being dramatic. They mean it literally. The silence window. This span of time when 3 Atlas is unobservable from Earth strips away capabilities we normally take for granted. You might think, well, it's just a few weeks, we'll catch it on the way out. But you'd be missing the point. Those few weeks are everything. First, spectroscopy goes dark. Spectroscopy is how we read the chemical signature of objects in space. Light passes through or reflects off a comet's coma and tail, and that light gets split into its component wavelengths, creating a fingerprint of elements and molecules. Water vapor, carbon dioxide,
Look at that crater.
cyanide, ammonia, sodium. Each one leaves a mark.
Incredible.
Each one tells us what the comet
Dust
is made
storms
of,
swirl
what's
around them
boiling
as
off
they
its
approach.
surface, how active it is. Without spectroscopy, we're flying blind on composition. If Atlas suddenly starts outgassing something unusual during conjunction, we won't know. Second, we lose precise astrometry. Astrometry is the measurement of position and motion. Every time we observe Atlas, we refine our understanding of its trajectory. Small corrections accumulate into accurate predictions. But if the object does anything unexpected during the blind phase, anything that changes its velocity or direction even slightly, our preconjunction trajectory won't match post-conjunction observations. We'll be left trying to reverse engineer what happened, playing detective with incomplete clues. Third, imaging goes away entirely. We won't see if Atlas fragments. Comets do this. They break apart. Sometimes it's gradual, chunks carving off like icebergs. Sometimes it's catastrophic, the nucleus shattering into pieces that spread out along the orbit. If Atlas fractures during perihelion, we won't witness it happening. We'll only see the aftermath, a debris field where a single object used to be, and we'll have to guess at the mechanism and timing. This is why perihelion during conjunction is such a problem. Perihelion is when everything happens. The object is moving at peak velocity, sometimes over 100,000 kilometers per hour relative to the Sunday. Solar heating is maximum, thermal stress is maximum, tidal forces, the stretching effect of gravity are maximum. This is the moment of maximum drama, and it's exactly the moment we're missing. Here's an analogy. Imagine you're watching a car race, and the fastest part of the track, the part where drivers push their limits and crashes, are most likely is hidden behind a building. You see the cars go in. You see them come out, but you have no idea what happened in between. Did someone spin out? Did someone pull ahead? Did someone pull an impossible maneuver? You won't know until you see the aftermath. And even then, you're guessing. Historically, other comets have passed behind the Sunday. It's not unheard of. But none of them were interstellar visitors reaching perihelion during conjunction. None of them carried the mystery that Atlas does. Every previous case involved objects we tracked for years. Objects with predictable orbits and well understood behavior. Atlas is different. We've known about it for less than 4 months. We're still learning what it is, and now we're about to lose sight of it at the worst possible time. The practical effect of this silence window is that many observatories will shift focus. Why dedicate telescope time to an object you can see? Other targets will take priority. Funding and scheduling demand efficiency. This means that when Atlas does re-emerge, there might be a lag before observations ramp back up. Opportunistic observers, the amateurs, and smaller institutions might be the first to catch it again. Professional networks will follow. But those first few days after re-emergence are critical, and we might miss details if everyone's slow to respond. There's also the psychological dimension. Scientists rely on continuous observation to build confidence in their models. Gaps introduce uncertainty. The longer the gap, the more uncertainty grows. When you're dealing with an interstellar object, something that's already anomalous by definition, uncertainty is uncomfortable. You want data. You want confirmation. You want to rule out the weird possibilities. The silence window doesn't let you do that. And let's address the elephant in the room. What if something deliberate happens during conjunction? I'm not saying it will. I'm not saying Atlas is artificial. But the question exists whether we like it or not. If you were designing an interstellar probe and wanted to do something without being observed, perihelion during conjunction would be the perfect moment. Maximum energy available, maximum speed, complete invisibility from Earth. You could release smaller probes, you could adjust trajectory, you could do a dozen things that would be obvious if anyone were watching, but nobody is. Again, natural explanations are far more likely. Outgassing, fragmentation, thermal cracking, these are all normal, but the timing creates a gap in the story, and gaps invite speculation. The longer the gap, the more speculation grows. By the time Atlas re-emerges, people will have imagined 100 scenarios and will have no way to confirm or deny most of them. The silence window doesn't just hide the object, it hides the truth. So, we're left with a waiting game. The object goes dark, weeks pass, solar observatories catch hints. Maybe if we're lucky, ground-based telescopes stand idle, pointed at other corners of the sky, and somewhere behind the sun, hidden in glare and distance, Atlas continues its journey, moving fast, heating up, possibly changing, possibly staying the same. We won't know which until it's over. The curtain has fallen, the lost act begins, and whatever happens next happens in darkness. Part 3. Orbital Puzzles. Now, let's dig into something strange about Atlas's trajectory. When an interstellar object enters our solar system, we expect it to come from basically any direction. Space is three-dimensional. There is no preferred orientation. Objects should arrive from above the plane of the solar system, below it.
One fragment
angled,
plunges into the great
randomly
red spot.
scattered across the sky. But 3-2 Atlas didn't do that. It came in nearly aligned with the ecliptic plane, tilted only about 5 degrees from the orbital plane of Earth and the other planets. That's unusual. The ecliptic plane is the flat disk where Earth and the major planets orbit the Sun. If you picture the solar system as a dinner plate, the ecliptic is the surface of that plate. Most solar system objects live near this plane because they all formed from the same rotating disk of gas and dust billions of years ago. But interstellar visitors didn't form here. They have no reason to respect our plane. They should come from random angles. So, why is Atlas so politely aligned? Maybe it's coincidence. Statistics allow for outliers. You flip a coin 100 times. Sometimes you get 10 heads in a row. Doesn't mean the coin is rigged. Atlas could just be that one object that happened to arrive along the ecliptic by chance. But when you start adding up the coincidences, the neat arrival angle, the timing of conjunction and perihelion, the trajectory that takes it near several planets while hidden, the picture gets harder to dismiss as pure luck. Astronomers have tried to backtrace Atlas's orbit to find where it came from. You take the current trajectory, run the math backward through time, and see if it points to any known star system. This works for some interstellar objects. Borisov, for example, could be loosely traced to a region of space consistent with being ejected from a young star system. But Atlas, no clear origin. The backtrace points generally toward the constellation Sagittarius, toward the galactic center, but no specific parent star emerges from the data. It's like the object appeared from nowhere or from somewhere too far and too scrambled by galactic gravitational influences to pinpoint. There's also the matter of velocity. Since Atlas was discovered in July, observers have collected astrometric data to refine its orbit. Some of those data points suggest the object is moving slightly faster than pure gravitational models predict, or that its trajectory has a small non-gravitational components. This could be outgassing, which is normal for comets.
Like origami,
when ice vaporizes on one side of the
light.
nucleus, it acts like a tiny thruster, gently pushing the comet off course.
It unfolds
We see
like
this
origami,
all the time.
made of
But
metal
with Atlas,
and light.
the deviations are subtle, and we haven't been observing long enough to be certain what's causing them. Natural outgassing, internal activity, or something else. Let's talk about perihelion distance. Atlas will reach approximately 1.35639 astronomical units at its closest approach, about 203 million kilometers from the Sun. That's comfortably outside Earth orbit, which is 1 astronomical unit. It's closer than Mars, but not dramatically. So, the specific time is October 29th, 2025 at 11:34 and 35 seconds terrestrial time. The precision of that number is itself interesting. We can calculate orbits with incredible accuracy when we have enough data, but all that precision assumes the object behaves predictably. If Atlas does something unexpected during conjunction, our carefully calculated perihelion time might be slightly off, and we won't know until after the fact. Here's where things get speculative, and I want to be clear about that. Some recent papers in astrophysics discuss the idea that galactic structure creates what you might call gravitational corridors. These aren't physical tunnels.
It's a message.
They're regions of space where the combined gravity of stars, gas clouds, and dark matter creates paths of
It's a
slightly
message.
lower gravitational resistance. Objects traveling through these corridors might follow similar trajectories across vast distances, the way rivers follow valleys. It's fringe theory, not mainstream, but it's being studied. If such corridors exist, they could explain why multiple interstellar objects might arrive from similar directions. The Sagittarius corridor, if it exists, could be one such pathway. Let's be honest about what we're dealing with here. The natural explanation is simplest. Atlas is an old comet ejected from its home system millions of years ago, wandering the galaxy until it happened to pass through our neighborhood. Orbital dynamics are complex. Gravitational interactions over time can scramble trajectories until tracing them becomes impossible. The ecliptic alignment could be coincidence. The timing could be coincidence. The velocity anomalies could be normal outgassing. All of these are reasonable defensible positions, but the alternative explanation exists, and ignoring it doesn't make it go away. If Atlas were artificial, if it were a probe designed by an intelligence with access to interstellar travel, the trajectory makes more sense. You'd want to enter a star system along the ecliptic because that's where the planets are. You'd want your closest approach during conjunction because that's when you have maximum energy and minimum observation. You'd want to pass near multiple planets, Mars, Venus, Jupiter, while hidden to gather data or release smaller instruments. This isn't proof, it's not even evidence. It's just noting that an engineered trajectory and the observed trajectory look suspiciously similar. Avive has said in his usual provocative way that Atlas deserves attention, not because it's definitely artificial, but because the alignment of unusual factors suggests we shouldn't dismiss the possibility without thorough investigation. Most astronomers disagree. They point out that extraordinary claims require extraordinary evidence, and we don't have that evidence. A weird orbit isn't enough. Odd timing isn't enough. You need a smoking gun, a clear techno-signature, something that can't be explained naturally. And so far, we don't have that. But here's the tension. The smoking gun, if it exists, might reveal itself during the period when we can't see. If Atlas is going to do something artificial, change course, deploy instruments, signal someone, it would do so during conjunction, and we'll miss it by the time the object re-emerges and we can observe it again. The moment will have passed. We'll be left with before and after pictures trying to deduce what happened in the middle. So, the orbital puzzles remain. Where did Atlas come from? Why is it aligned with the ecliptic? What's causing the velocity anomalies? Are we seeing a natural visitor or something deliberately placed?
Connection established
The trajectory
between
may
distant
hold
worlds.
secrets, but those secrets are about to become a lot harder to read. Part 4, Sky's counterpoint.
Distant
While
worlds.
3 Atlas prepares to vanish, the night sky isn't cooperating with the somber mood. In fact, around October 20th, the sky is putting on a show. 2 bright comets, Comet C divided by 2025 A6, known as Lemon, and Comet C divided by 2025 R2, called Swan, are both visible to observers in the northern hemisphere. If you know where to look, and if you're lucky enough to have dark skies, you might catch them glowing green just after sunset. It's a strange duocession. Two comets lighting up, one disappearing. Comet Lemon was discovered on January 3rd, 2025 by observers using the Mount Lemmon survey in Arizona. Since then, it's been brightening steadily as it approaches Earth. On October 21st, just as Atlas enters conjunction, Lemon reaches its closest approach to Earth at about 0.6 astronomical units, roughly 90 million kilometers. That's not particularly close by comet standards, but it's close enough that under dark skies, away from city lights, the comet should be visible to the naked eye. Observers report a greenish hue, which comes from diatomic carbon glowing in sunlight. It's a classic comet color, the kind that makes people stop and stare. If you want to see Lemon, look toward the northwest horizon after sunset. It won't be high in the sky, maybe 15 or 20 degrees above the horizon, so you'll need a clear view. Binoculars help if you're in a light-polluted area. Through binoculars, the comet appears as a fuzzy green smudge with possibly a faint tail extending away from the sunday. It won't look like the comets in textbook photos. Those are long exposures. Visual comets are subtler, but there's something primal about seeing one with your own eyes. Knowing you're looking at a dirty snowball from the outer solar system, shedding ice and dust as it hits. Then there's Comet Swan, discovered more recently on September 10th, 2025 by the Solar Wind Anisotropies instrument aboard the Solar and Heliospheric Observatory. Swan specializes in detecting hydrogen emissions, which makes it good at finding comets before they're bright enough for ground-based searches. This particular comet reaches its closest approach to Earth around October 21st as well, at approximately 40 to 50 million kilometers. It's positioned low in the southwestern sky after sunset, another twilight target. Swan's visibility is less certain than Lemon's. Predictions suggested it might reach naked eye brightness, but comets are notoriously unpredictable. They can flare unexpectedly or fizzle out. As of mid-October, reports indicate Swan is visible but faint, requiring binoculars or a small telescope. Still, the fact that two comets are peaking around the same time as Atlas's conjunction creates a visual narrative. Look up on October 20th or 21st.
Ocean tides
You might see two visitors from the outer solar system,
as
both
gravity
reflecting
trembles.
sunlight, both shedding material, both putting on a display. And while you're looking at them, remember that the third visitor, one from another star entirely, is slipping out of view. There's also the Orionic meteor shower, which peaks around October 20th and 21st every year. The Orionids are debris from Hall's comet, tiny particles left behind on Hall's orbit that Earth plows through annually. When these particles hit Earth's atmosphere at 70 kilometers per second, they vaporize in streaks of light, meteors, shooting stars.
You see that?
The Orionids aren't the strongest shower.
What is that?
Maybe
What is
20
that?
meters per hour under ideal conditions, but they're fast and often leave persistent trains. If you're already outside watching comets, you might catch a few meteors streaking across the sky. So, the sky on October 20th is busy. Lemon in the northwest, Swan in the southwest, Orionid meteors radiating from the constellation Orion in the east.
Inside,
It's a cosmic traffic jam,
microscopic structures
multiple phenomena
rearranged
competing
like
for your
living
attention.
code.
And somewhere behind the sun,
It's
unobservable and unremarked by most, Atlas continues its hidden journey. There's a thematic contrast
It's learning.
here worth noting. Lemon and Swan are visible, they're accessible. Anyone with a clear horizon and a pair of binoculars can see them. They're part of the shared human experience of watching the sky. The same experience our ancestors had thousands of years ago when they tracked comets and made up stories about them. Atlas, on the other hand, is invisible. It's known only through data, through orbital calculations and scientific instruments. Most people don't even know it exists, and the few who do know can't see it. It's hidden not just by the sun, but by its own nature. an interstellar intruder operating on a scale and trajectory that defies easy observation. You could argue that the two visible comets are a distraction. While the world's amateur astronomers point their telescopes at Lemon and Swan, while social media fills with green comet photos, Atlas does whatever it's going to do behind the scenes. Out of sight, out of mind, the spectacle draws the eye while the real story unfolds elsewhere. Maybe that's overthinking it. Maybe it's just coincidence that three comets occupy the same window. But coincidences are piling up, and at some point you start to wonder. If you do go outside to watch the comets, take a moment to think about what you're seeing. Lemon and Swan are solar system natives, probably kicked out of the Kuiper Belt or Oort cloud by gravitational perturbations. They've been orbiting the sun for billions of years, looping out to the cold darkness and swinging back toward warmth. Atlas is different. It came from outside. It's passing through, never to return, following a hyperbolic trajectory that will eventually carry it back into interstellar space. Three comets, two you can see, one you can't, two that belong
Satellites
here,
capture
one
the
that
phenomenon
doesn't.
in real time.
The sky offers a mirror. Visibility versus invisibility, spectacle versus stealth, the obvious versus the hidden. And as Atlas slips behind the sun, as the night sky lights up with its more cooperative cousins, we're reminded that sometimes the most important things are the ones we can't see. Part 5, the countdown. We're down to hours now. Less than 24 hours before 3 Atlas
Its
crosses the
descent is
invisible
slow,
line and
deliberate,
becomes
controlled.
unobservable from Earth. This is the decision window. The last chance to gather data
Its
before the
descent is
silence
slow,
begins.
deliberate,
Across the
controlled.
world, observatories that can still see Atlas are scrambling. Final
breaks
spectra,
apart high above the
last
ocean.
images, closing astrometric measurements. Every photon counts. Telescope time is
breaks
expensive and
apart
competitive.
high above the ocean.
Major observatories book months in advance. You submit proposals. You justify why your target deserves the time. You wait
Each
for
fragment
approval. But
lands
when
softly
something
on
urgent
different
comes up,
continents.
when an object of interest is about to vanish, the system can flex. Some observatories have directors' discretionary time slots reserved for time-sensitive observations. Atlas qualifies. This is a once-in-a-lifetime event. The first interstellar object to go through perihelion during conjunction.
Strange
If we
magnetic
don't observe
readings
it now,
spread
we
worldwide.
never will. Amateur astronomers are also involved, and this is worth appreciating. You don't need a billion-dollar facility to contribute. A decent backyard telescope, a CCD camera,
People report
some
dreams
processing
of
software,
stars and alien
and you can
voices.
capture astrometric data or photometry that professionals will use. The asteroid and comic community relies on a global network of observers, many of them hobbyists, who track objects and report their findings. When something like Atlas comes along, the amateurs mobilize. They share coordinates. They compare notes. They post images online. It's citizen science at its best. A collective effort to squeeze as much information as possible out of a fleeting opportunity. But there are rumors circulating, and this is where things get murky. Some reports suggest that spectroscopic observations of Atlas have revealed unusual composition data that hasn't been publicly released yet. Embargoed results waiting for peer review. The specifics are vague. Lower water content than expected, odd ratios of nickel or cyanide, nothing definitive, nothing published, just whispers in the astronomical community. Are these rumors credible? Hard to say. Science moves slowly. Preliminary results often don't survive scrutiny, but the rumors exist and they add to the intrigue. Why would composition matter? Because it tells us what the object is made of, which tells us where it came from. Comets from the outer solar system have certain chemical fingerprints. Comets from the inner regions have others. Interstellar comets should theoretically show compositions reflecting their origin, perhaps enriched in certain volatiles or depleted in others, depending on the conditions in their home system. If Atlas's spectrum is genuinely anomalous, If it doesn't match any known population of comets, that's scientifically interesting.
They shimmer
It
like
suggests
emerald
formation
fireflies.
conditions we haven't seen before. Or if you're inclined towards speculation, it suggests something else entirely. But let's not get ahead of ourselves. Unverified rumors are just noise until they're confirmed. The scientific process exists for a reason. Data needs to be checked, rechecked, peer-reviewed, and published before we treat it as real. Until that happens, we are left with speculation, which is entertaining but not reliable. For those of you with access to a telescope, Atlas
Observe.
is still technically visible,
Do not
though
fear.
faint. Magnitude estimates put it around 13 or 14, well beyond
Observe.
naked eye visibility.
Do not fear.
You'll need a moderately large telescope, at least 8 inches of aperture, and you'll need to know exactly where
We
to
are
look.
running out of time.
Ephemerales,
I am
tables
on
of
it.
predicted positions are available from the Minor Planet Center.
Prepare all
and other
systems for
sources.
immediate deployment.
Point your telescope, take a long exposure, and you might capture one of the last images of Atlas before it vanishes. Will it matter? Probably not scientifically, but there's something meaningful about being part of the observation, even in a small way. As the hours tick down, there's a psychological shift happening among those paying attention. Anticipation mixed with dread. We're about to enter a period of not knowing. The object continues its journey, but we lose our connection to it. It's like watching someone walk into a tunnel. You see them enter, you wait, eventually they should emerge on the other side. But while they're inside, while they're hidden, you can't help but wonder what's happening in there.
Its surface
Are they
glows
okay?
like
Are
liquid
they the
metal.
same? Did something change? The tension is heightened by the fact that this isn't just any object. This is an interstellar visitor. Only the third we've confirmed.
The ship
These are
pulses,
rare. We don't know
absorbing
how
them
often they
as
pass
fuel.
through. We don't know if we'll see another one next year or next century.
The ship
Missing this
pulses,
one,
absorbing
missing
them
the
as
most
fuel.
interesting part of his journey, feels like a lost opportunity on a cosmic scale. And then there's the timing. Perihelion 8 days after conjunction. Maximum speed, maximum energy, maximum heating, all occurring while invisible. If you were writing a thriller, you couldn't script it better. The protagonist enters the danger zone just as the cameras go dark. What happens next? We'll find out when the protagonist emerges. But until then, we're left in suspense. So, what will we do with the time while Atlas is hidden? Most people will forget about it. Life continues. News cycles move on. The story fades into background noise. But for those who are watching, those who understand what's happening, the waiting is the story, the silence is the plot. And the question, what will Atlas look like when it comes back? Becomes
Each
the
piece
hook
drifts
that keeps us
upward,
engaged.
merging into orbit.
In just hours, the countdown ends. The object crosses into conjunction.
Each piece
Our
drifts
view
upward,
goes dark. And for
merging
several
into
weeks,
orbit.
we wait in that darkness, hoping that when the light returns, the story makes sense. Hoping that the object that emerges is the same one that went in. Hoping that the answers we find are the ones we expect. But hope and expectation are two different things, and in space,
The fragments
nothing is ever
arrange
quite
into
as simple
perfect
as we want it to
circles.
be. Part 6. The Sagittarius Corridor Hypothesis. Let's zoom out and look at a pattern that might not be a pattern at all. Multiple anomalies. 3-eye Atlas, 1 eye, divided by Oumuamua, even the famous WOW signal from 1977. All point roughly toward the constellation Sagittarius. That's the direction of the galactic center, the crowded hub of our Milky Way galaxy. Is this meaningful, or are we doing what humans do best? Finding patterns in randomness? The Sagittarius Corridor Hypothesis, and I want to be clear, this is speculative, suggests that certain directions in the galaxy might act as preferential routes for interstellar objects. Think of it like this. On Earth, we build roads where the terrain allows, rivers carve valleys, animals follow game trails. We take paths of least resistance. Could something similar happen on a galactic scale? Gravitational wave cytography, a relatively new field in net astrophysics, maps the large-scale structure of space-time, shaped by massive objects,
The same
galaxy
symbol
clusters,
appears, a
supermassive
spiral of
black
stars.
holes, dense molecular clouds. All of these warp space-time
symbol
in ways
appears,
we can now
a
detect
spiral of
and model.
stars.
Some researchers propose that these warps create corridors, regions where an object traveling through space encounters slightly less gravitational interference. It's not that space-time is physically different, it's that the cumulative effect of mass distribution creates pathways that objects might naturally fall into over millions of years. If this is true, and again this is a big if, then objects entering our solar system from the direction of Sagittarius might be following such a corridor. Atlas came in aligned with the ecliptic, tilted about 5 degrees. Previous interstellar candidates also showed trajectories loosely consistent with this general direction. Mua's Origen, when back rays pointed vaguely toward the galactic plane. The WOW signal, that brief burst of radio detected by Ohio State's Big Ear telescope on August 15, 1977, came from Sagittarius. Add them up and you start to see a cluster of interesting events associated with one region of the sky. But correlation is not causation. Sagittarius is a large constellation covering a significant portion of the sky. The galactic center lies in that direction, which means there's more stuff, more
It turns
stars,
toward the
more
camera,
potential
watching
source
us.
regions. It's also where we tend to point our telescopes when searching for interesting phenomena. Selection bias is a real problem in astronomy. We find what we look for, and we look where we expect to find things. So maybe the Sagittarius connection is just an artifact of where we're paying attention. Still, the idea of a galactic corridor is intriguing.
It's the size
If
of
advanced
an entire
civilizations
solar
exist and
system.
they travel between stars, they might use these corridors the way we use trade routes. Low energy, efficient, predictable. You wouldn't launch a probe in a random direction. You'd aim for a corridor that increases your
movement
chances of
bends
encountering
light,
something interesting.
forming
Earth
halos
lies
of
in the
color.
galactic plane, in a relatively active region of star formation. If you're traveling
Its
down the
movement
Sagittarius
bends
corridor,
light, forming halos
you'd
of
pass
color.
through our neighborhood eventually. This raises a question that's uncomfortable for many scientists. Are we looking at natural debris drifting along gravitational pathways, or are we looking at engineered objects using those same pathways deliberately? The physics works either way, natural or artificial. The trajectory would look similar. An engineered probe wouldn't need to do anything obviously artificial. It would just follow the path of least resistance, blending in with natural travelers. Aviv has pointed this out in his writings. He's not
It lands
claiming
softly
Atlas
on a
is
quiet
artificial.
planet covered in
He's
oceans.
saying that the trajectory and timing are consistent with what an artificial object
It lands
might do.
softly on
And
a quiet
therefore,
planet
we should
covered in
investigate
oceans.
thoroughly. Most of his colleagues push back, arguing that invoking aliens without direct evidence is premature. They're right, of course. Extraordinary claims require extraordinary evidence, but Low's counter-argument is that if we don't look, if we dismiss possibilities because they seem unlikely, we'll never find evidence even if it exists. The wow signal is worth revisiting in this context. On August 15, 1977, the Big Ear radio telescope at Ohio State detected a strong narrowband signal
From orbit,
lasting 72
it looks
seconds.
like a fractal city
The
beneath
signal
the
was
sea.
so unusual that astronomer Jerry Eman wrote,
From orbit,
"Wow,"
it looks like
in
a
the margin
fractal
of the
city
printout,
beneath the sea.
giving the event its name. The signal came from the direction of Sagittarius, specifically near the constellation Chi Sagittarii. Attempts to detect it again have failed. 48 years later, we still don't know what it was. Was the wow signal artificial? Possibly. Was it natural? Also, possibly. Could it have been interference? Maybe. The point is, we don't know. And the fact that it came from roughly the same direction as some interstellar objects adds a layer of curiosity. If you're playing Connect the Dots,
It's alive and
Sagittarius
intelligent.
has a lot of dots.
They
But let's
realized
be careful.
light
Drawing
It's
lines
alive
between unrelated
and
events is
intelligent.
how conspiracy theories start. The WOW signal and Atlas are separated by nearly 50 years and involve completely different phenomena. One is radio, one is a physical object. Linking them requires assumptions
ocean
we can
speaks
justify.
through
At best, we
vibrations
can know
of
the
light.
directional coincidence and file it away
Communication
as
established.
interesting but not
Light
conclusive.
for language.
The corridor hypothesis also has natural explanations. The galactic
Communication
center is
established.
gravitationally dominant.
Light for
Objects in
language.
that region experience stronger tidal forces and more complex dynamics. Material
ocean
ejected from
reveals
star
its origin,
systems near the center
seeded by the
might
meteor.
naturally spread along certain trajectories determined by the combined gravity of billions of stars. Over millions of years, you'd accumulate a population of objects traveling along preferred paths, not because they're engineered, but because gravity shapes their motion. So where does that leave us? The Sagittarius corridor is a hypothesis, not a theory. It's an idea that deserves investigation, but hasn't been proven. The alignment of Atlas, MMU, and other anomalies might be meaningful, or might be coincidence amplified by human pattern recognition. We need more data. We need more interstellar objects to track. We need better models of
Earth
galactic
receives
structure
faint
and
echoes
gravity.
of that same
Right
signal
now, we're
decades
working with a
later.
sample size of 2 confirmed
Earth
interstellar
receives faint
objects,
echoes of
possibly
that
3
same
if you
signal
count Atlas.
decades later.
That's not enough to establish a pattern. But here's
It
what
matches
makes
the
this
3
relevant
eyes
to
slash
Atlas's
Atlas
conjunction.
patterns.
If the object is following a
Okay.
natural corridor, then its passage through the solar
The data
system
matches.
is just physics playing
matches
out.
the
If
3i
it's following
slash
an
Atlas
engineered
patterns.
route, if the corridor is being used deliberately, then the timing and trajectory take on different significance. The fact that Atlas reaches perihelion while hidden could be navigational strategy rather than cosmic accident. We won't resolve this question during conjunction. We won't resolve it when Atlas re-emerges.
All over the world,
We might not
people look
resolve
up
it
in awe.
for decades. But the question sits there waiting. Are we seeing random travelers from the cosmic wilderness? Or are we seeing traffic on a galactic highway? Objects moving with purpose along established routes. The corridor hypothesis is one way to frame the mystery. It suggests that space isn't as empty and random as we assume.
Astronomers
that there are
have confirmed
structures,
that these distant
pathways,
stars are actually
patterns
pulsing.
we're only beginning to detect. And if those patterns exist,
Astronomers
if the
confirm
galaxy has corridors carved
distant
by gravity
stars
and
are
time,
pulsing
then
back.
maybe we're not as isolated as we think. Maybe the space between stars is more traveled than
A
we realize.
cosmic dialogue
And maybe, just
begins.
maybe, we're finally noticing the traffic. Part 7. The Data Suppression Debate. Now, we need to talk about something uncomfortable. There's a conversation happening in corners of the internet and among some amateur astronomers about data suppression. The claim is simple but serious that observation data for certain objects, particularly those that might be unusual or anomalous, gets delayed, classified, or withheld by space agencies and institutions. Is this happening? And if so, why? Let's start with what we know. Astronomy operates on peer review and public data release, at least in principle. When you make an observation, you eventually publish it. Data archives exist specifically to make information available to the global community. The Minor Planet Center collects astrometry. Sky surveys release imaging data. Spectroscopic databases share chemical analysis. This openness is fundamental to how science works. Independent verification requires access to data. But there are exceptions. Some observations have proprietary periods where the team that collected the data gets exclusive access for a set time before public release. This is standard practice. If you spend years designing an instrument and months collecting data, you get first crack at analyzing and publishing
colossal
results.
shapes move
Proprietary
the
periods can last months or even a
Within
year.
it,
During that
colossal
time,
shapes move
the data
across
isn't public and other
ancient,
researchers can
gentle
use it.
beings.
Is this suppression? Not really. It's protecting intellectual investment, but from the outside, it looks like information being withheld. Then there are national security considerations. Ground-based telescopes and space-based assets sometimes detect objects that governments consider sensitive. Military satellites, debris from classified missions, near-Earth objects that might pose impact risks before mitigation strategies are in place. In these cases, data might genuinely be classified or delayed to avoid public panic or reveal capabilities. Does this happen? Almost certainly. How often? Hard to say. The nature of classification means we don't know what we don't know. When it comes to 3i Atlas, there are rumors unverified and unsourced that some spectroscopic data has been held back. The reasoning given is that preliminary results need confirmation before publication. This is legitimate. You don't want to announce something dramatic based on noisy or uncertain measurements only to retract it later when better data shows you were wrong. Science has been burned by premature announcements, cold fusion, faster than light neutrinos, arsenic-based life. Each case damaged credibility and taught the lesson. Check your work before going public, but delay creates suspicion. If Atlas shows something unusual in its spectrum, something that doesn't fit natural comet models, researchers might sit on that data until they're absolutely certain. Peer review takes months. Revisions take more months. By the time a paper is published, the conjunction will be over. Atlas will have re-emerged and the story will have moved on. During that gap, people speculate. They assume the worst. They imagine cover-ups. Are there legitimate reasons for data suppression beyond scientific caution? Possibly, if Atlas was showing signs of artificial origin, if there were technosignatures in the data, you could argue that releasing that information prematurely would cause global disruption. Governments might want time to assess, to coordinate, to prepare statements. International protocols for contact with extraterrestrial intelligence exist. Frameworks for how to handle such a discovery. Those protocols assume deliberate decision and not rushed announcements driven by social media pressure. On the other hand, astronomy is a global enterprise. Atlas is being observed by telescopes in multiple countries. Amateur astronomers are tracking it. Independent teams are collecting data. Suppressing information across such a distributed network is nearly impossible. Someone would leak. Someone always leaks. The history of whistleblowing in science and government shows that secrets don't stay secret for long. So, what's the reality? Most likely, there's no grand conspiracy. What we're seeing is the ordinary messiness of science. Data takes time to analyze. Results need validation. Papers need writing and review. Some information might be delayed for legitimate reasons, caution, or proprietary periods. Other information might be classified for national security, though probably not the bulk of Atlas observations. And some rumors are just rumors, speculation dressed up as insider knowledge. But the conjunction creates a perfect storm for suspicion. The object goes dark, we can observe it. Whatever happens during that window happens unseen. When Atlas re-emerges, we'll only know what instruments catch and what researchers choose to share. If there's a gap between what happened and what we're told, we'll have no way to verify. The black box of conjunction becomes a black box of information. Citizen science becomes crucial here. Independent observers,
by energy
amateurs
drawn from
with backyard telescopes, they're the check on institutional control. They can collect data that doesn't go through official channels. They can share findings online without waiting for peer review. They're not subject to the same pressures or constraints as professional astronomers. If something interesting happens with Atlas post-conjunction, if the object looks different or behaves strangely, amateurs will notice and report it. That distributed network of eyes makes suppression harder. There's also the question of what data even means in this context. If Atlas fragments during conjunction will see fragments when it re-emerges, that's observable fact, hard to suppress. But the interpretation, the explanation for why it fragmented, that's where control enters. Was it natural thermal stress, tidal forces, or something else? The data might be public, but the narrative around it can be shaped. Historical parallels exist. The unidentified aerial phenomena discussion, the UFO topic, has shown how government delay in acknowledging observations can fuel conspiracy theories. For decades, official policy was denial or dismissal. Then suddenly, acknowledgement. Yes, we've been tracking unexplained objects. Yes, some remain unidentified. The gap between what was happening and what was admitted created a trust deficit that persists today. The same could happen with interstellar objects. If institutions aren't transparent, so are we trusting what we'll see or what will be told? Ideally, those should be the same thing. Observation should be public, data should be accessible, interpretation should be debated openly, but the reality is more complex. There are always gaps between observation and announcement. The question is whether those gaps are innocent delays or deliberate obfuscation. For Atlas, we won't know until post-conjunction data emerges, and we can compare independent observations with official statements. The data suppression debate isn't about proving a conspiracy. It's about recognizing that information flow in science and government isn't always straightforward. There are pressures, incentives, and constraints that affect what gets shared and when. Being aware of those factors doesn't make you paranoid. It makes you informed. And when dealing with something as unprecedented as an interstellar object disappearing during perihelion, being informed means questioning, verifying, and demanding transparency. The black box of conjunction is about to close. When it opens again, we'll see what's inside. But whether we see everything or only what we're meant to see, that's a question we should keep asking. Part 8. The log factor. You can't talk about interstellar objects and speculation about artificial origins without talking about Avive. He's become the controversial figurehead of the what if it's a probe conversation, and his involvement with 3 Atlas adds fuel to an already interesting fire. So who is Avive? What's his argument? And why does it matter? Avive is a professor of astrophysics at Harvard University. He's the former chair of the astronomy department. He's published hundreds of papers on black holes, cosmology, and high-energy astrophysics. By any measure, he's a serious scientist with serious credentials. He's not a fringe figure. He's not someone you can easily dismiss. And that's exactly what makes his positions on interstellar objects so provocative. Lo first gained widespread attention with his analysis of one eye divided by Oumuamua, the first confirmed interstellar object discovered in 2017. Mua was strange. It was elongated, tumbling, and showed a small acceleration that couldn't be explained by gravity alone. Most astronomers attributed the acceleration to outgassing, the standard explanation for comets behaving oddly. But Lo proposed an alternative. What if Oumuamua was a light sail, a thin reflective sheet pushed by solar radiation pressure, possibly artificial? The suggestion was explosive. The scientific community largely rejected it, arguing that natural explanations, while imperfect, were far more likely than invoking extraterrestrial technology. Lo stood his ground. He wasn't claiming Oumuamua was definitely artificial. He was claiming that the artificial hypothesis shouldn't be dismissed without investigation. Extraordinary claims require extraordinary evidence, yes, but extraordinary dismissal requires extraordinary justification. If we don't look, we'll never find. Now, Lo has turned his attention to Atlas. In a preprint article, he points out the unusual alignment of conjunction and perihelion. October 21st for conjunction, October 29th for perihelion, 8 days apart. He notes the ecliptic alignment, the trajectory that passes near multiple planets while hidden, the timing that coincides with maximum energy and minimum observation. He doesn't claim Atlas is artificial.
We are
He says
connected.
it deserves attention, that it's
Connected.
extraordinary, that coincidence or design is a question worth asking. His critics, and there are many, argue that this is sensationalism, that by raising the artificial possibility, even cautiously, Law lends credibility to a speculation that has no basis in evidence, that he's conflating unusual with artificial, which is a logical leap the data doesn't support. They point out that space is full of unusual things.
On the surface,
rare events happen,
alien
low
cities
probability
power up,
outcomes occur
synchronized
given
to the
enough
orbit.
trials. The fact that Atlas's timing is odd doesn't mean it's engineered. Law's response is philosophical. He argues that science advances by exploring possibilities, not dismissing them prematurely, that the burden of proof works both ways. If you're going to claim
ground
something is natural,
trembles.
you should be able to explain it convincingly.
statues
If
begin to
natural
move.
explanations are strained, if you have to invoke multiple improbable factors, then alternative explanations deserve consideration, not acceptance. Consideration.
They rise
So,
like whales,
what
breaching a
specific
cosmic
data
ocean.
does LOE highlight? The perihelion distance 136 astronomical units places Atlas in a zone
The debris
where solar
becomes new
heating
moons
is significant
orbiting the
but
planet.
not catastrophic. It's close enough to activate a comet, but not close enough to destroy it. The timing of perihelion, 8 days after conjunction, means the object reaches maximum speed and energy while invisible. If you are planning a maneuver, a trajectory adjustment, or a deployment of instruments, this would be the ideal moment. Maximum energy via the Oath effect. Maximum privacy from Earth-based observation. He also notes the planetary encounters. While hidden behind the Sun, Atlas's trajectory takes it relatively near Mars, Venus, and Jupiter. Not close encounters, but within observational range if the object had instruments capable of data collection. This isn't proof of anything. Natural comets pass near planets all the time, but the pattern planets during invisibility adds to the list of factors that are individually explainable but collectively curious. Lovaas founded the Galileo Project, an initiative to search for evidence of extraterrestrial technological artifacts. The project uses telescopes and sensors to monitor the sky for anomalies that might indicate artificial objects. Atlas fits the profile of something the Galileo project would investigate, not because it's proven to be artificial, but because it's sufficiently unusual to warrant scrutiny. If we're serious about searching for techno-signatures, we can't ignore candidates just because they might turn out to be natural. Why do mainstream astronomers resist Lowe's approach? Several reasons. First, the prior probability. The likelihood that any given interstellar object is artificial is vanishingly small. Interstellar travel is hard. Energy requirements are enormous. The number of civilizations that could build such probes, if any, exist at all, is unknown. Betting on artificial origin without clear evidence is betting against overwhelming odds. Second, the reputational risk. Astronomy has been burned by premature claims. Pulsars were briefly called LGM signals, little green men, before being identified as neutron stars. The face on Mars turned out to be a trick of light and shadow. Crying alien too often damages credibility.
The
Third,
archive
there's a
reveals
concern that
galaxies
focusing on
connected through
artificial
thought.
explanations distracts from legitimate science. Studying Atlas as a natural object yields data on interstellar chemistry, orbital dynamics, and cometary activity. Treating it as a potential
Astronomers
probe shifts
realize it's
focus
the
to
same
speculation
meteor
that might be
across
unproductive. Time and resources are limited. Do we spend them chasing long shots or studying known unknowns?
It never fell.
Low's counter is
It's
that we
planned.
can do both. That
It traveled.
investigating artificial possibilities
The
doesn't
meteor
preclude
becomes a
natural
vessel
research.
made of memory.
That by ruling out the artificial hypothesis rigorously, we actually strengthen our understanding of natural phenomena, and that if we never look, if we dismiss the possibility out of hand, we guarantee we'll miss it, if it's there. The tension here is fundamental to how science handles edge cases. Do you follow the data wherever it leads, even into uncomfortable territory? Or do you apply Occam's razor ruthlessly, favoring the simplest
The ship is
explanation
alive,
until forced to abandon it?
synchronized
Both
with life
approaches have
itself.
merit. Both have produced breakthroughs. The question is, which one applies to Atlas? So,
Cosmic
what does the
rays
load
bend
factor
around
mean
its
for our
hull
story?
like liquid
It
glass.
means the artificial origin hypothesis stays on the table, at least in public discourse. It means that when Atlas reemerges, people will be watching not just for natural activity, but for signs of something else. Changes in trajectory, unexpected fragments, signals, anything that doesn't fit the comet playbook. Law has set the stage for heightened scrutiny, and whether you agree with his approach or not, that scrutiny will shape how we interpret what we see. If Law is even partially correct,
It
if
emerges
there's a
near
1%
planet
chance
covered
Atlas
entirely
is
in
something
mirrors.
other than a comet, then the blind window during conjunction becomes the
Each
most critical
mirror
phase of the
reflects a
entire
different
event.
timeline.
The phase where something might happen that we can't observe. The phase where the reveal, if there is
The
one,
meteor
occurs
hovers,
off stage.
choosing one
And if
reflection
he's
to
wrong,
enter.
if Atlas turns out to be exactly what conventional wisdom
Inside the
says
chosen
it is,
timeline,
a natural
Earth is
interstellar
oceanic
comet
and
following
untouched.
physics and nothing more, then the whole exercise will be remembered as an interesting detour. What if that didn't pan out? But either way, the lobe factor has ensured we're paying attention, and in science, attention is the first step toward discovery. Part 9. The energy puzzle. Let's talk about energy, specifically about why perihelion during conjunction is such a
Life
powerful combination
beneath the
if you're
surface
thinking about
glows
spacecraft
with new
maneuvers. This
awareness.
involves a concept from orbital mechanics called the Oath effect, and understanding it explains why the timing of 3 Atlas matters so much. The Oath effect is named after Hermann Obath, one of the founding fathers of rocketry. The principle is simple but profound. A rocket burn at high speed produces more change in kinetic energy than the same burn at low speed. Or, to put it another way, if you want to change your trajectory as efficiently as possible, you do it when you're moving fastest. For Atlas, that moment is perihelion, October 29th, when the object is closest to the Sun
Each
and moving at
branch
peak velocity. Here's the
like
math
a
in simple
tuning
terms.
fork
Kinetic energy is
in the
1/2
wind.
mass time velocity squared. That square term matters. If you're moving at 10 kilometers per second and you add 1 kilometer per second via a rocket board,
Their trails
your
form
kinetic energy
circles of
increases
light
proportional
around
to
the
your
planet.
final velocity square minus your initial velocity
One
square.
by
But if you're
one,
moving at 50
they
kilometers per
fade,
second and at the same 1 kilometer per
leaving
second, the
silence.
energy change is much larger because of that square factor.
In that silence,
You get more bang
the
for your buck
planet
at high
breathes
speed.
a stay.
For comets and asteroids, this usually doesn't matter. They're not performing burns. They're just falling through gravity wells, passive objects following Newtonian physics. But if Atlas were artificial, if it had any capacity to change its trajectory, perihelion would be the moment to do it. A small impulse at perihelion yields a large change in orbital energy, allowing significant trajectory alteration with minimal fuel. This is exactly what spacecraft engineers use for gravity assists and orbital maneuvers. Now add the conjunction fact. Atlas reaches perihelion 8 days after entering solar conjunction. That means the highest energy moment of its trajectory occurs while Earth-based telescopes are blind. If you wanted to perform a maneuver
within,
and observe, you
shadowed
couldn't pick better
forms
timing.
emerge to make.
Maximum energy gain, maximum privacy, it's almost too convenient. Natural processes can also release energy at perihelion, and this
They
is the
place each
conventional
lantern in
explanation
orbit,
for any
forming
oddities.
a constellation.
Comets heat up as they approach the Sunday subsurface, ices vaporize, pressure builds, jets of gas and dust erupt from the nucleus, acting like tiny rockets.
That
This
gallop
outgassing
pulses
creates the
in
classic comet
response.
tail and can produce measurable changes in trajectory. We see this all the time. It's normal, but the magnitude and timing matter. If Atlas undergoes massive outgassing exactly at perihelion, that's expected. If it releases fragments, also expected. Comets are fragile. Thermal stress cracks them. Tidal forces from the sun's gravity can pull them apart. None of this requires artificial intervention, but if Atlas does something energetically improbable, something that requires more energy than natural outgassing provides, that's when questions arise. There's also the solar energy context. At 136 astronomical units, Atlas receives about half the solar illumination that Earth does. That's still substantial. If the object has any kind of solar collection capability, if it's using photovoltaics or thermal systems, perihelion is when it has maximum power available. Again, purely speculative, but the alignment of high speed, high solar flux, and invisibility creates a window where many things become possible. Let's consider what a trajectory change at perihelion might achieve. If Atlas were to slow down or speed up significantly, it could alter its eventual exit trajectory from the solar system. Natural comets live on hyperbolic orbits similar to the ones they arrived on, just deflected slightly by the sun's gravity. But a deliberate burn could change that. The object could aim for a different target, another star system, along its path. Or it could release smaller probes on divergent trajectories, each heading toward different destinations. The energy available at perihelion makes these maneuvers feasible in ways they wouldn't be elsewhere in the orbit. Observational implications
Earth's
would be clear
telescopes
if
capture
we
it
could
and
observe.
recognize the pattern.
Sudden brightening would indicate energy release. Changes in tail morphology
It matches
would
the
show
ancient
altered
carvings from
outgassing
Mars's
patterns.
crater.
Fragments separating from the main body would be visible as distinct points of light. Trajectory deviations would show up in astrometric measurements. But all of these signatures require observation, and observation is exactly what we don't have during conjunctions. This creates an asymmetry. Natural explanations and artificial explanations both predict activity at perihelion. The difference lies in the details, the magnitude and specificity of that activity. Without observation, we can't distinguish between them. We're left inferring what happened based on before and after snapshots, which is always uncertain. The natural versus engineered debate comes down to probability and parsimony. Natural processes are known. We've studied hundreds of comets. We understand thermal evolution and outgassing. We know that unusual things happen, but they're explainable within physics. Engineered
bow
explanations
slowly,
require invoking technology we've never
acknowledging
seen,
humanity's
civilizations
awakening.
we've never contacted, capabilities we can only imagine. Occam's razor says, go with the simpler explanation, but Occam's razor isn't a law of nature, it's a heuristic. Sometimes the simpler explanation is wrong. What would constitute proof of artificial origin? Direct detection of technology, a radio signal, a visible structure inconsistent with natural formation, trajectory changes that violate momentum conservation unless you account for expelled mass in specific ways, chemical signatures indicating industrial processing. Any of these would be smoking guns, but they all require observation, and observation is denied during the critical window. So, the energy puzzle remains unsolved. We know perihelion is when energy conditions are most favorable for activity, natural or artificial.
A
We know
new
the
dawn
timing
rises,
coincides with
the
conjunction,
first light of the
maximum
galactic
invisibility. We know that if anything significant happens, this is when it happens. But we won't see it. We'll only see the results. And interpreting results without process is always ambiguous. The object is moving fast now, accelerating as it falls toward the Sunday. In just days, it reaches peak velocity, peak heating, peak energy, and peak invisibility. Whatever Atlas is gonna do, whatever it's capable of doing, the moment approaches and we're about to miss it. Part 10. Coincidence or choreography? Let's step back and look at the full picture, all the factors we've discussed, and ask a simple question. Are we seeing coincidence or choreography? How many unusual alignments can you stack before probability becomes implausible? Start with the trajectory. 3 Atlas enters the solar system aligned within about 5 degrees of the ecliptic plane. Most interstellar objects should come from random angles. The ecliptic alignment is unusual but not impossible. Probability of ecliptic alignment might be generously 10%. Unusual, noteworthy, but within the realm of chance. At the timing, conjunction on October 21st. Perihelion on October 29th, 8 days apart. The object's closest approach occurs while invisible from Earth. How often does this happen? For interstellar visitors, we don't have statistics. We've only seen 2 before Atlas, and neither did this. But for solar system comets, conjunction during perihelion is rare. Maybe 1 in 50 comets experiences this. So, another 2% factor at the direction. Atlas comes from the general direction of Sagittarius toward the galactic center. So did Oumuamua, roughly, so did the WOW signal. Sagittarius covers maybe 5% of the sky, another factor of 0.5 at the planetary encounters. While hidden, Atlas passes within observational range of Mars, Venus, and Jupiter. Not close flybys, but trajectories that place it where a probe with instruments could gather data. How many random trajectories do this? Hard to calculate precisely, but let's say 10%. Multiply these probabilities. If you assume independence 0.1 times 0.0, 2 times 0.05 times 0.1 equals 0.01, or 1 inch 100,000. That's not impossible. Unlikely things happen, but it's starting to stretch credibility. Now add the velocity anomalies. Small deviations from purely gravitational predictions, possibly explained by outgassing but not definitively. Add the rumors, spectroscopic oddities, unconfirmed and unpublished. Add the fact that all this occurs during a period of heightened solar activity, during a meteor shower, during a dual comet display in the night sky. Each factor individually is explainable. Together, they form a pattern that's harder to dismiss. Here's the counter-argument. Humans are pattern recognition machines.
Life is the
We see
universe
faces and
dreaming
clouds.
of itself.
We see conspiracies and coincidences. Cognitive biases like confirmation bias and the clustering illusion make us overweight. Unusual alignments and underweight base rates.
Each reflection
If you look at enough
is a
data,
world,
you'll find patterns.
a moment,
Some will be
a
meaningful.
memory.
Most will be noise. The challenge is distinguishing which is which. The naturalist position is that Atlas is noise, an interstellar comet with a weird orbit and unfortunate timing. Nothing more. The universe is big. Random events cluster. We're seeing one such cluster, and mistaking it for design. Given enough interstellar objects over enough time, one of them will have all these factors aligned by pure chance. Atlas happens to be that one. The choreography position is that the alignment is too specific, too convenient, that invoking chance repeatedly for each individual factor eventually becomes less parsimonious than invoking intent. That if something looks designed, acts designed, and follows patterns consistent with design, maybe it is designed, not proven, but possible enough to investigate seriously. There's a philosophical dimension here. Are we part of a cosmic conversation we don't understand? The idea isn't new. Carl Jung explored it in Contact. Arthur C. Clarke in Rendezvous with Rama. The notion that intelligence might communicate not through radio signals, but through objects, artifacts, probes
Light
that carry
scatters like
information
pollen
physically across
cosmic
interstellar
wind.
distances. If such a system exists, a galactic messaging network, we'd expect to see objects with unusual trajectories, strange timing, patterns that
Meteorito
hint
verde,
at intent,
aproximándose
but
rápidamente a la
expectation isn't evidence.
Solicito
Science fiction
confirmación de
isn't
trayectoria e
science.
impacto
The
potencial.
burden of proof remains on those claiming something extraordinary, and right now we don't have that proof. We have suggestive data, interesting
Meteorito
coincidences,
verde,
and
aproximándose
a lot of
rápidamente a la Tierra.
speculation. There's also the
Solicito
mirror symmetry
confirmación
to
de
consider.
trayectoria e
Our
impacto
own Voyager
potencial.
probes are heading outward, carrying golden records with information about humanity. Voyager 2 is heading roughly toward the constellation Telescopium, but its trajectory will eventually curve due to galactic dynamics. Over millions of years, it might pass through regions near Sagittarius. If another civilization found Voyager, they'd see an artificial object on an interstellar trajectory, following a path shaped by gravity and intent. Are we seeing the equivalent? Someone else's Voyager inbound instead of outbound, following a corridor that brings it through our neighborhood. It's a poetic idea. The cosmos as a place of exchange where civilizations send emissaries in the form of probes, knowing they'll arrive long after the senders are gone. Messages in bottles cast into the galactic ocean. Some arrive, most don't, but the ones that do carry stories, data, evidence of other worlds. Yet, poetry isn't proof either. The universe doesn't care about our narratives. It operates on physics, not metaphor. If Atlas is a prop, it's a prop because it was built to be one, not because we want it to be one. And if it's a comet regardless of how much we wish otherwise. So, where does that leave us? Suspended between coincidence and choreography, unable to prove either, waiting for Atlas to re-emerge and give us more data. The object itself doesn't care about our debate. It follows its trajectory, natural or engineered, indifferent to our speculation, but we care. We have to care, because if there's even a chance that the pattern is real, that the choreography exists, then missing it would be the greatest oversight in human history. The conjunction window is closing. The object slips behind the sun, and we're left with our questions, our doubts, our hopes. When Atlas returns, when we can see it again, will the pattern resolve into clarity, or will it remain ambiguous, forever balanced between interpretations? A cosmic Rorschach test reflecting our own assumptions back at us. Coincidence or choreography? The answer might already be written in the trajectory. We just have to wait for the object to reappear so we can read it. Part 11. Quantum Communication Breakthroughs. While we're waiting for 3i Atlas to re-emerge from behind the sun, let's talk about something happening right now in October 2025 that might change how we think about communication across interstellar distances. Humanity is on the verge of deploying operational quantum communication networks, and this development has implications for how we search for and potentially miss signals from other civilizations. In October 2025, the European Space Agency and Chinese space programs have reported successful satellite-based quantum entanglement experiments across continental distances. These aren't lab demonstrations anymore. These are functional systems transmitting secure information using entangled photon pairs. The principle relies on quantum mechanics, specifically the phenomenon where two particles become correlated in such a way that measuring one instantly affects the other regardless of distance. Now, quantum entanglement doesn't allow faster than light communication in the traditional sense. You can't send a message instantly across space by measuring entangled particles. The no communication theorem in quantum mechanics forbids it. But what you can do is create communication channels that are fundamentally secure, unhackable by any classical means, because any attempt to intercept the signal destroys the quantum state. For secure communication, quantum networks are revolutionary. But here's the connection to interstellar objects. For the past 70 years, our search for extraterrestrial intelligence has focused almost entirely on radio signals. We point radio telescopes at the sky. We listen for narrowband transmissions, patterns that couldn't occur naturally. We assume that advanced civilizations broadcast either deliberately or accidentally, and that we can detect those broadcasts if we look hard enough. This assumption underlies every SETI program ever funded. What if that assumption is wrong? What if radio is a phase, a technological adolescence that civilizations grow out of? Humans used radio for barely a century before developing alternatives. fiber optics, laser communication, and now quantum networks. If this progression is common, if civilizations naturally transition from broadcast radio to directed laser to quantum entanglement, then we're looking for a signal that might not exist anymore. We're searching for smoke signals in an age of encrypted quantum channels. Imagine an advanced civilization thousands or millions of years ahead of us. Would they still use radio? Probably not. Radio is inefficient. Broadcast in all directions. Leaks information to anyone listening. A mature civilization would use tight beam lasers for point-to-point communication, minimizing energy waste and maximizing security. And eventually, they transition to quantum networks, which offer perfect security and potentially new physics we haven't discovered yet. If such networks exist, if there's a galactic quantum internet connecting civilizations, we'd be invisible to it. Our radio telescopes can't detect quantum entanglement. We don't even know what to look for. It would be like trying to join the internet using a telegraph. The infrastructure exists, the traffic flows, but we're using technology from a different era, unable to interface with the modern system. This has direct relevance to Atlas. If the object is artificial, if it's a probe from a civilization with advanced technology, it might not communicate using methods we can detect. It might not broadcast. It might not emit radio signals. It might link into a quantum network during perihelion, transmitting data we can intercept, receiving instructions we can't observe. And because this happens during conjunction, while we're blind, we'd never know it occurred. This isn't wild speculation. This is extrapolating from our own technological development. If we're building quantum communication satellites in 2025, a civilization even a few centuries ahead of us would have mature quantum networks. A civilization millions of years ahead, we can't even imagine their communication methods. They might use gravitational waves. They might manipulate space-time directly. They might use principles of physics we haven't discovered. The historical context matters. 50 years ago, we assumed radio was the universal communication medium. Its electromagnetic radiation travels at light speed, easily generated and detected. Any technological civilization would use it. But now we're not so sure. Radio might be training wheels, a phase you pass through before adopting more sophisticated methods. If that's true, then SETI's decades of listening might have been aimed at the wrong frequency, literally and figuratively. Does this mean SETI is pointless? Not necessarily. Young civilizations, ones like us, would still use radio. We might detect their broadcast during the radio loud phase. But older civilizations, the ones capable of building interstellar probes, might be radio silent, and detecting them would require different methods. Optical SETI, looking for laser pulses. Infrared searches, looking for waste heat from megastructures. Gravitational wave monitoring. Technosignature searches, focusing on atmospheric pollution or industrial byproducts in exoplanet
The energy
spectra.
readings
Or
from
we
that
could look for the
sector are
probes themselves.
unusual.
Physical artifacts traveling through space, interstellar objects with unusual trajectories, things like Atlas. If civilizations don't broadcast, but instead send emissaries, probes carrying information physically, then detecting those probes becomes our best chance at contact. And if we're not paying attention, if we dismiss unusual objects as natural without thorough investigation, we miss the message. The quantum communication breakthrough in October 2025 reminds us that technology evolves. What seems cutting edge now will be obsolete in decades. What seems impossible now might be routine in centuries. If we're searching for signals, we need to update our assumptions constantly, always asking what we might be missing, what methods we haven't considered, what channels we're not monitoring. For Atlas, this means the absence of a radio signal doesn't mean absence of communication. The object could be transmitting in ways we can't detect. It could be listening in ways we can't jam. It could be part of a network we don't even know exists, and the conjunction window, that period of invisibility, might be when it joins that network, uploads data, downloads instructions, does whatever its mission requires. Or it could be a rock, a comet, a piece of interstellar debris with no more intelligence than a brick. We don't know. But the possibility that we're tuned to the wrong frequency, that we're missing signals all around us because we're using outdated methods, that possibility should keep us humble and curious and always questioning whether we're really seeing the whole picture. The quantum revolution is here. The universe might have already had its quantum revolution millions of years ago, and we're just now catching up, blinking in the light of technologies we barely understand, wondering what else we've been missing. Part 12. AI and cosmic data. In October 2025, another breakthrough is quietly reshaping astronomy. A new machine learning system, details still emerging, has been applied to archival gravitational wave data and SETI datasets, uncovering 14 previously undetected events from the past decade. 14 signals or patterns that human analysts missed. 14 needles that were always in the haystack but invisible until artificial intelligence pointed them out. This matters because astronomy is drowning in data. Every night, survey telescopes capture terabytes of images. Every second, gravitational wave detectors record strain measurements. Every hour, radio telescopes collect spectra from thousands of sources. Human astronomers can't analyze it all. There's too much. So, we filter, we prioritize, we look at what seems interesting and ignore the rest. And in doing so, we miss things. Machine learning changes the game. Algorithms can process millions of data points simultaneously. They don't get tired. They don't have biases about what's interesting. They find patterns humans overlook, correlations buried in noise, anomalies that violate expectations in subtle ways. The 14 detections reported in October are proof that we've been missing signals all along. Not because they weren't there, but because we weren't looking correctly. Apply this to 3 atlas. Right now, observatories are collecting final measurements before conjunction, images, spectra, astrometry. That data gets stored in archives. Humans look at it, extract the obvious features, publish papers on composition and trajectory, standard procedure. But what if there are patterns in that data that humans can't see? Subtle periodicities in brightness, unusual correlations between spectral lines, trajectory deviations that are individually within error bars but collectively significant. An AI trained on comet behavior might flag atlas as anomalous, even if human analysts don't. The real power comes post-conjunction. When atlas re-emerges, we'll collect new observations. Comparing before and after requires careful analysis. Did the object fragment? Did its brightness change? Did its trajectory shift? Human astronomers will do this work, but they'll look for obvious differences, large changes, clear signatures. AI can go deeper. It can detect 3% brightness variation that might indicate surface changes. It can identify trajectory shifts measured in meters divided by s. It can compare spectral fingerprints and notice that the specific emission line ratio changed by an amount statistically significant but visually imperceptible. This has already happened in other contexts. Exoplanet detection was revolutionized by machine learning algorithms that found planetary transits in Kepler data that humans had classified as noise. Gravitational wave astronomy uses AI to distinguish real events from instrumental artifacts. Fast radio burst detection relies on algorithms sifting through radio data automatically. In each case, AI didn't replace human astronomers. It augmented them. It found things humans would have missed, allowing humans to follow up and confirm. For interstellar objects, AI could be transformative. We've only confirmed 3: Oumuamua, Borisov, and now Atlas. But how many did we miss? How many objects passed through the inner solar system with unusual trajectories that weren't flagged because they were faint or moved too fast or appeared in data that wasn't scrutinized carefully? AI applied retroactively to decades of archival sky surveys might reveal a dozen more interstellar visitors hiding in plain sight. There's also the question of what AI might hallucinate. Neural networks sometimes find patterns that aren't real, artifacts of training data or algorithmic quirks. A false positive is worse than a misdetection because it wastes resources chasing ghosts. So AI results need validation. Humans need to check the machine's work, verify that detected patterns hold up under scrutiny. This slows the process but ensures reliability. But imagine this scenario. Atlas re-emerges in late November. Observatories collect data. Initial human analysis shows nothing unusual. The object looks like a comet, behaves like a comet, matches prejunction predictions. Case closed, natural object, move on. But then, someone runs the data through an AI pipeline trained on anomaly detection. The algorithm flags something. A periodicity in the light curve that doesn't match rotation. A subtle trajectory change consistent with a small impulse. A spectral feature that appeared post-conjunction but wasn't there before. Small things individually questionable. But the AI assigns high confidence to the combined pattern. Do you investigate? Do you take the AI seriously? Or do you assume it's a false positive algorithmic noise not worth the effort? This is the new frontier of astronomy. Trusting machines to guide human investigation. Balancing algorithmic insight with human judgment. Getting it right could mean discovering something extraordinary. Getting it wrong could mean missing it or wasting time on illusions. There's also the computational volume issue. Searching for interstellar objects means scanning the entire sky constantly, tracking millions of moving points of light, calculating trajectories, checking for hyperbolic orbits. Humans can't do this at scale. We rely on automated systems, and those systems rely on algorithms. If the algorithms aren't sophisticated enough, if they filter out objects that move too fast or appear too faint, we miss visitors. Upgrading those algorithms with modern AI techniques could increase detection rates dramatically. The Vera C. Rubin Observatory, formerly known as LSST, is scheduled to begin operation soon. It will survey the entire visible sky every few nights, generating an unprecedented flood of data. Estimates suggest it will detect dozens of interstellar objects per year once it's running at full capacity. But only if the data pipeline can handle the volume. Only if AI systems can identify candidates in near real time. Only if humans can follow up quickly before objects fade or move out of range. The success of interstellar object science in the coming decade depends heavily on machine learning. For Atlas specifically, there's a possibility that hidden information will only emerge through AI analysis. Maybe the object left a signature in its prejunction data, a clue about what it might do during perihelion. Maybe that signature is too subtle for human detection, but obvious to a trained neural network. If so, we won't know until someone thinks to run the analysis. And if no one does, the information stays hidden, buried in archives, waiting for someone to ask the right question. This raises an existential point about the search for extraterrestrial intelligence. We assume we'll recognize a signal when we see it. But what if signals are structured in ways optimized for machine interpretation,
Confirming
not human
trajectory now.
interpretation? What if advanced civilizations broadcast using modulation schemes or error correction codes that look like noise to us, but would be obvious to a sufficiently advanced AI? We might be swimming in alien transmissions right now, unable to recognize them, because we're using human intuition instead of machine analysis. The same applies to physical artifacts. If Atlas is a probe, its design might incorporate features that are algorithmically detectable but visually ambiguous. Surface patterns, trajectory optimizations, spectral signatures, things that an AI trained on spacecraft design would flag instantly, but that human astronomers would dismiss as natural variation. We might need machines to recognize machines. So the question becomes, are we ready to let AI guide our search? Are we comfortable trusting algorithmic findings even when they conflict with human intuition? Can we build systems that balance machine efficiency with human judgment? These aren't just technical questions, they're philosophical ones. They touch on what it means to discover, to understand, to know. Atlas is hidden now, passing through its blind phase. When it re-emerges, human eyes will watch, but so will machine eyes. Neural networks trained on terabytes of astronomical data, ready to find patterns we can't see. Which eyes will see more clearly? Which will miss the obvious? Which will hallucinate ghosts? We'll find out soon enough. And the answer might determine whether we recognize the most important discovery in human history or scroll past it in a database flagged as noise. Part 13. Solar Storm Warnings. October 2025 isn't just bringing interstellar visitors and quantum breakthroughs. The sun itself is acting up. NOAA, the National Oceanic and Atmospheric Administration, has issued warnings about the strongest coronal mass ejection cycle since 2012. Solar storms are intensifying. Space weather is getting rough. And the timing, as with everything else this month, is uncomfortably coincidental. Coronal mass ejections are massive eruptions of plasma and magnetic field from the sun's corona. When they are aimed at Earth, they can wreak havoc. The charged particles slam into Earth's magnetosphere, compressing it, inducing currents in power grids, disrupting satellites, interfering with radio communication. They also produce spectacular auroras, the northern and southern lights, as particles spiral along magnetic field lines and excite atmospheric gases. We're currently in the ascending phase of solar cycle 25. The sun's activity follows an 11-year cycle of increasing and decreasing magnetic complexity. Solar maximum, the peak of activity is approaching. That means more sunspots, more flares, more coronal mass ejections. October 2025 sits right in this active period, and recent observations show several large active regions on the sun's surface capable of producing major eruptions. Here's the irony. As 3 Atlas disappears behind the sun itself might interfere with observations of everything else. Solar storms degrade telescope performance. They create ionospheric disturbances that affect radio astronomy. They damage satellite instruments. They force spacecraft to enter safe mode. In effect, the sun is hiding Atlas while also blinding our other observational tools. It's a double blackout. There's also the question of whether solar activity affects Atlas directly. The object passes within about 23 million kilometers of the sun at perihelion. That places it well within the sun's extended atmosphere, the heliosphere, where solar wind and magnetic fields are significant. Comets at that distance experience the solar wind, a stream of charged particles flowing outward from the sun at hundreds of kilometers divided by s. This wind pushes comet tails away from the sun, creating the classic appearance we associate with comets. But coronal mass ejections are different. They are transient, intense bursts of plasma traveling faster than the normal solar wind. If a coronal mass ejection happens to pass through Atlas's location during perihelion, the comet could experience a sudden increase in particle flux and magnetic field strength. For a natural comet, this might trigger enhanced outgassing or tail activity. For an artificial object, who knows? Maybe nothing. Maybe something detectable. We won't know because we can't see. Solar storms also pose challenges for the spacecraft that might observe Atlas during conjunction. SOHO, the Solar and Heliospheric Observatory, orbits the Sun-Earth L1 Lagrange point, positioned between the Sun and Earth. It's designed to monitor solar activity. So it's somewhat hardened against radiation, but intense storms can still affect its instruments. Parker's solar probe flies closer to the sun than any spacecraft has before, currently on a trajectory that will eventually take it within about 6 million kilometers of the solar surface. It's extremely radiation tolerant, but even Parker has limits. If solar activity spikes during Atlas's passage, observational data from this spacecraft might be compromised. Stereo. The Solar Terrestrial Relations Observatory consists of two spacecraft that orbit the Sun at different positions, providing stereoscopic views of solar phenomena. Stereo could theoretically catch Atlas from an angle not blocked by the Sun's glare. But solar storms fill the interplanetary medium with noise, making faint objects harder to detect. It's like trying to spot a candle during a fireworks display. The signal-to-noise ratio collapses. For people on Earth, the silver lining of solar storms is auroras. If a coronal mass ejection hits Earth's magnetosphere around October 20th or 21st, auroras could be visible at unusually low latitudes. Normally confined to polar regions, strong storms can push the auroral oval down to mid-latitudes. People in the northern United States, southern Canada, northern Europe might see shimmering curtains of green, red and purple light dancing across the sky. It's beautiful. It's also a reminder that space isn't empty. It's full of plasma, fields and energy. There's a darker side to solar storms. Power grids can be damaged by induced currents. In 1859, the Carrington event, the strongest solar storm in recorded history, induced currents so intense that telegraph systems caught fire. If a Carrington-level event happened today, the damage to modern infrastructure would be catastrophic. Estimates suggest trillions of dollars in economic impact and years of recovery time. We're better prepared now than we were in the 19th century, but we're also more dependent on electronics, satellites, GPS, communication networks, all vulnerable. Noise warning for October doesn't predict a Carrington-level event, but it does suggest elevated activity. Minor to moderate storms are expected. That means some satellite disruption, some radio blackouts, some beautiful auroras, and some interference with astronomical observations during exactly the period when we'd most like clear data. The narrative connection between Atlas and solar storms is tenuous but tantalizing. Both involve the Sunday, both peak around the same time. Both introduce uncertainty into what we can observe. Is the Sun hiding Atlas deliberately? Of course not. The Sun doesn't have agency. It's a ball of fusing hydrogen following plasma physics. But the alignment, yet another alignment, adds to the sense that October 2025 is cosmically busy. There's also the invisibility theme. Atlas is invisible because it's behind the Sunday. Solar storms create a different kind of invisibility. Interference and noise that obscure observations. Even objects we should be able to see become harder to detect. When the electromagnetic environment is chaotic, invisibility has many forms. Geometric, spectral, temporal. Sometimes you can see because something's in the way. Sometimes you can see because there's too much going on. Either way, the result is the same: ignorance. If you're outside watching Comet Lemon or Comet Swan around October 20th, check Aurora alerts. Apps and websites provide real-time space weather forecasts. If a storm is inbound, if the KP index spikes, head somewhere dark and look north, you might see something incredible. And while you're watching the sky light up with auroras, remember that those lights are caused by particles from the Sunday, the same sun that's currently hiding an interstellar visitor. The sun gives, the sun takes away. And right now it's taking away our view of something we desperately want to see. Soon we'll shift gears again, moving from solar storms to black holes, from the nearest star to the galactic center. But the theme persists. Signals, noise, hidden messages, things we can't see directly but infer from echoes and effects. The universe is full of invisible information, we just have to learn how to read it. Part 14. Black Hole Echo Studies. While 3 Atlas hides behind the Sun, astronomers studying the opposite end of the cosmic scale have reported something fascinating: new observations of Sagittarius A star. The supermassive black hole at the center of our galaxy show evidence of X-ray and radio echoes. These are signals that bounce, persist, and reverberate across vast stretches of space-time, leaving footprints that can be detected long after the original event. Sagittarius AAR, often abbreviated as SCAR-R, sits about
Their
26,000
hulls shimmer
light-years
with
from
fluid,
Earth,
metallic
in the direction of the
reflections.
constellation Sagittarius. Yes, the same Sagittarius that keeps appearing in our story. The black hole itself has a mass of roughly 4 million suns packed into a region smaller than Mercury's orbit. It's relatively quiet as supermassive black holes go, not currently devouring large amounts of material, but it flares occasionally, and those flares leave traces. The echoes being studied come from material falling into SGA star, possibly from a past feeding event decades or centuries ago. When matter spirals into a black hole, it heats to millions of degrees and emits X-rays. Some of those X-rays travel outward and reflect off gas clouds surrounding the black hole. Because the clouds are at different distances,
Each
the reflected
pod
light
lands near
arrives
the
at
meteor's
different times.
crater.
We see echoes, delayed images of events that happened in the past, light that took the long way around. This phenomenon is called a light echo, and it's not unique to black holes. Supernovae produce light echoes. Variable stars produce them. Any transient event that illuminates surrounding material can create echoes. But black hole echoes are special because they probe the structure of space-time itself. The way light bends near the event horizon, the way time dilates, these effects leave signatures in the echo patterns. By studying the echoes, astronomers can map the environment around the black hole and test general relativity in extreme conditions. Why does this matter for our Atlas story? Because echoes represent delayed signals, information that persists and becomes accessible long after the original event. If you think about interstellar objects as potential messengers, they might function the same way. Not sending signals in real time, but leaving traces, signatures, physical evidence that can be detected later. A probe doesn't need to broadcast, it just needs to exist, to pass through, to leave something behind, an echo in the form of trajectory, composition, or artifacts. The Sagittarius connection is also worth noting. We keep coming back to this constellation, Atlas inbound from Sagittarius, possibly from that direction, the wow signal from Sagittarius, SGAR in Sagittarius. The galactic center, the gravitational hub of the Milky Way, sits there. If you're mapping galactic structure, if you're trying to understand how matter and information flow through the galaxy, Sagittarius is central. It's the anchor point, the reference frame. Some speculative papers, and I emphasize speculative, suggest that gravitational wave echoes from black hole mergers might create long-lasting perturbations in space-time. These perturbations could theoretically affect the trajectories of objects passing through certain regions, creating corridors or pathways where travel is slightly easier or more predictable. It's fringe physics not accepted by mainstream astrophysics, but it's been explored mathematically. If such corridors exist, they naturally connect to regions near massive gravitational sources, like the galactic center. This ties back to the corridor hypothesis from earlier. If objects follow gravitational pathways shaped by black holes and dark matter, then the echoes we see from SCAR might be part of a larger picture. Signals bouncing through space-time, objects following routes carved by gravity, information propagating across the galaxy, not as electromagnetic waves, but as physical motion through structured space. There's also a temporal aspect. Echoes are fundamentally about time. An event happens, time passes, the echo arrives. For black holes, this can span years or centuries depending on the geometry. For interstellar objects, the time scale is even longer. An object is ejected from its home system millions of years ago. It travels through the galaxy. It arrives at our solar system. We detect it. In a sense, we're seeing an echo of whatever event created the object. A supernova ejecting debris, a planetary system disrupted by a passing star, or perhaps a civilization launching a probe. The object itself is the echo, delayed information from a distant event. If Atlas is artificial, if it's a probe, then it's an echo of an intelligence that might no longer exist. The civilization that built it could have gone extinct thousands or millions of years ago. The probe travels on carrying its message, its purpose, oblivious to whether its creators still live. It's a sobering thought that we might detect evidence of intelligence that's already vanished. That first contact might be with a ghost, an artifact outliving its makers. But even natural
passes
objects
near Saturn,
are echoes
scattering
in this
green
sense.
dust into the
Comets
rings.
are remnants of solar system formation. Interstellar
It
comets
passes near
are
Saturn,
remnants of other
scattering
system
green dust
formation.
into the
Every
rings.
rock, every icy body, every grain of dust tells a story about the past. Astronomy is the study of echoes. We don't see events as they happen. We see them as they were, light years or millions of years delayed. The universe we observe is a museum of echoes, frozen moments arriving in sequence. The black hole studies remind us that information
What
persists.
is that?
It bounces, it
What are we
hides, it
seeing?
re-emerges. Light
Oh
that
my
seems
God.
lost can be found again, reflected off distant clouds, bent by gravity, scattered by dust. Nothing truly disappears. It just becomes harder to find. And with the right tools, the right methods, the right questions, we can reconstruct events from their echoes. When Atlas re-emerges from conjunction, we'll be looking at an echo, not of light, but of motion. The object will have passed through perihelion unseen. Whatever happened there is already history. We'll see the aftermath, the echo of that hidden event, and we'll try to reconstruct what occurred. It's detective work, reading echoes, inferring causes from effects. The same work astronomers do when studying black holes, supernovae, or the cosmic microwave background. The universe is full of echoes. Some we can read, some we can't. Some are loud and obvious. Some are faint whispers, requiring decades of observation and sophisticated analysis. Atlas is about to add its echo to the cosmic record, and whether that echo tells a story of natural ice and rock or something more, we won't know until we listen carefully to what the silence has to say. Part 15. The mirror turned on us. As we close this story, let's turn the mirror around. We've spent 14 parts examining 3i Atlas, asking what it is, where it came from, what it might mean. But there's another question equally important that we haven't fully addressed. If someone is watching us, would we even know? And more fundamentally, are we ready to be observed? October 2025 is witnessing global discussions about autonomous decision-making in space, AI, ethics, summits, debates about autonomous weapon systems in orbit, discussions
The
about the
skyline
space debris
flickers gray,
management, and
powered
satellite
by energy
constellation.
drawn from
Humanity is at a
meteors.
transition point, moving from a species that merely observes space to one that operates in it, builds in it, potentially fights in it. We're becoming a spacefaring civilization, messily and chaotically without a unified plan or ethic. Think about what an outside observer would see. Earth broadcast radio and television signals that leak into space. Radar installations sweep the sky. Satellite constellations reflect sunlight. Our atmosphere shows chemical signatures of industrial activity, methane and chlorofluorocarbons that wouldn't exist naturally. We're loud, we're visible, we're advertising our presence whether we intend to or not. The Voyager probes, Pioneer plaques, Aurbo message, these were deliberate attempts to say hello. But our real message is everything else. The totality of electromagnetic noise, the swarm of satellites, the altered atmospheric chemistry, that's what a distant observer would detect first. Not a carefully crafted message, but the aggregate mess of a technological civilization that hasn't figured out stealth or efficiency. If Atlas is artificial, if it's here observing, what does it see? A planet in crisis, wrestling with climate change, political instability, resource depletion, a species with incredible technology but questionable wisdom. We split the atom and built bombs. We connected the world and created echo chambers. We reached the moon and then stopped. We're capable of extraordinary things and also capable of extraordinary foolishness. Would an advanced civilization want contact with us? That's not a given. Maybe they'd observe from a distance, taking notes, waiting to see if we mature or collapse. Maybe they'd intervene. Maybe they'd avoid us entirely, marking our system as too volatile, too unpredictable. We don't know. We can't know. But the question matters because it affects how we think about contact and whether we're even desirable as partners in a cosmic community. There's also the question of what we're hiding intentionally or not. Near-Earth space is crowded with satellites, most of them untracked or poorly catalogued, debris from decades of launches, dead satellites, fragments from collisions, all orbiting in chaotic clouds. From outside, this might look like defensive infrastructure, a shell of technology surrounding the planet. Is it protective? Is it paranoid? An observer couldn't tell the difference between legitimate space activity and militarization. Our own observational capabilities are improving rapidly. Telescopes like the James Webb Space Telescope can analyze exoplanet atmospheres for biosignatures. Future missions will directly image Earth-like planets around other stars. Within decades, we might detect industrial pollution in an alien atmosphere, confirming technological civilization without needing radio contact.
One
If we
fragment
can do
plunges
this,
into the great
others
red
can
spot.
too. The universe might be full of civilizations watching each other, inferring presence from chemical signatures, all waiting for someone else to make the first move. This creates a strategic dilemma. Do you announce yourself, risking unknown consequences? Or do you stay quiet, observing but not engaging, hoping to learn more before committing? Humanity has been accidentally announcing itself for a century. Our radio bubble expands at light speed, now over 200 light years in diameter. Any civilization within that bubble knows we're here or will know soon. The decision has been made for us. We're visible. So when Atlas re-emerges, when we analyze the data and try to determine what it is, we should remember that the analysis goes both ways. If it's observing us, it's collecting data too. Our response to its presence, our level of technological capability, our societal coherence or lack thereof. All of that is information. We're being judged, evaluated, assessed, and we don't control the narrative. This is why transparency matters. Why the data suppression debate from earlier isn't just academic. If we hide information from ourselves, if institutions withhold data or delay publication, we undermine our own ability to respond coherently to cosmic events. We fragment, we speculate wildly, we lose the thread. An advanced civilization watching us might conclude we're not ready. Not because of our technology, but because we can coordinate, can share information, can act collectively. The other aspect is preparedness. Are we ready for confirmation of extraterrestrial intelligence? Not in the abstract sense of philosophical readiness, but practically. Who speaks for Earth? Who decides how to respond? Do we respond at all? These questions have been debated for decades without resolution. International protocols exist, but they're not binding. In practice, if someone detects a signal or confirms an artifact tomorrow, chaos would follow. Media frenzy, government statements, religious reactions, scientific debates, all happening simultaneously, pulling in different directions. Atlas might not be that catalyst. Probably isn't. but it could be, or the next object could be, or the one after that. The point is, we need to get our house in order before the moment arrives. And by house, I mean our collective understanding of who we are, what we want,
It turns toward
and
the camera,
how we engage
watching us.
with the universe that might be watching. There's also the humbling realization that we might already be late to the party. If the galaxy has established civilizations, if there's a network, a community, a set of norms and protocols, we are the newcomers, the loud, clumsy species that just showed up.
It's the
We don't
size
know
of
the
an
rules,
entire
we
solar
don't speak the
system.
language, we're trying to figure out if anyone's even there while broadcasting our ignorance to anyone listening. Entonces, ¿qué hacemos con el tiempo mientras Atlas está oculto? Observamos,
Its movement
esperamos,
bends
nos
light,
preparamos, reflexionamos
forming
sobre lo que
halos of
significa
color.
ser parte de un cosmos más grande que nosotros mismos. Reconocemos que el
Its
silencio del
movement
espacio
bends
quizá
light,
no esté
forming
vacío,
halos of
sino
color.
lleno de conversaciones que no hemos aprendido a escuchar. Entendemos que la observación es una vía de doble sentido. Mirar hacia afuera significa ser visto. Cuando Atlas resurja, cuando los datos fluyan, los analizaremos con las mejores herramientas disponibles: telescopios, espectrógrafos, algoritmos de IA, percepción humana. Intentaremos responder a la pregunta: ¿qué es este objeto? Pero también deberíamos preguntarnos: ¿qué ve este objeto en nosotros? Porque si el espejo se invierte, si somos nosotros
It
los que
lands
estamos siendo
softly on a
observados,
quiet planet
la vista
covered in
podría no
oceans.
ser muy halagüeña. Y quizás, solo quizás, esa sea
It lands
la
softly
llamada
on
de
a quiet
atención que
planet
necesitamos.
covered in oceans.
El cielo siempre ha sido un espejo. Alzamos la vista y nos vemos reflejados en mitos y constelaciones. Los antiguos navegantes usaban las estrellas para orientarse. Los astrónomos modernos las usaban para comprender la física y los orígenes. Pero ahora el espejo es interactivo. Lo que enviamos regresa. Lo que observamos podría observarnos a cambio. Ya no estamos solos con nuestro reflejo. Alguien o algo podría estar mirando hacia atrás. El atlas de tres ojos se esconde tras el sol.
From orbit,
La cuenta
it looks
regresiva ha
like a
terminado.
fractal city
El
beneath the
silencio
sea.
comienza. Y en ese silencio esperamos
From orbit,
no solo la
it looks
reaparición
like a
del
fractal
objeto,
city beneath
sino la
the sea.
respuesta a lo que significa para nosotros, para ellos, para el universo que nos contiene a ambos. Anoten sus calendarios. Observen el cielo nocturno. Esté atento a los fenómenos lunares esta noche si el cielo está despejado. Busque meteoros orientados que sobrevuelan el cielo y recuerde que en algún lugar detrás del sol, invisible e inalcanzable, un visitante interestelar está haciendo historia, haciendo lo que ningún cometa ha hecho jamás.